All right, looks like everyone's in here. Hey everyone. Welcome to MongoDB World for probably the third, fourth time you've heard it today. Welcome to this presentation. So this session is going to be a 75-minute tutorial. Unfortunately, no Q&A at the end. It's going to be jam-packed. So if you'd like to talk with Joel, you can talk with him outside. But without further ado, I'd like to introduce Joel, who'll be talking to you about the Atlas Operator in Kubernetes today.
Thank you. Hi, everyone. Welcome to this presentation. As was just said, this was originally meant for like a 3-hour workshop, and I have 75 minutes, so this is gonna go fast. I tried to simplify it as much as I could. I'll be kind of live coding a little bit. If you want to follow along on your laptop, by all means. If everything goes well and you don't run into any sort of issues, you should be able to go and follow along as I do the live coding part. So this is the URL of the QR code if you want to access it. Even if you don't want to do it at the same time, pretty much everything that I'm going to present today, like all down to the slides that I have, is in this on this website. So you'll be able to just go through that website, do it at your own pace. Feel free to do it. Perfect. So welcome again for those of you who are just coming in. So to this talk, 3-tier application deployment in Kubernetes with the MongoDB Atlas Operator, which is by far the longest title I ever had for a talk. But again, trying to put in as much keywords as I can to get accepted to conferences. My name is Joel. I work as a developer advocate for MongoDB. And what are we going to do today? We will look at a MERN stack application, and we'll try to deploy that to a Kubernetes cluster. So just out of curiosity, who here is JavaScript developer? JavaScript developer? Any sort of developer? Who does containerization on a daily basis? Write their own? Not a lot. Perfect. Kubernetes? Good, good, some of you. Perfect, that's great. There's not a lot of hands, and that kind of reassures me because I'm actually going to introduce a little bit, go into the basics of what is a container, how to build your container images, and how to deploy everything into a Kubernetes cluster. So you'll have all the context that you need, at least for this specific application. So that's what we'll do today. We won't build the MERN application. I've kind of cut down that as part of the 1 hour of the 3 hours that was cut down right there. So I have an application. We'll just clone the repo, get all of the components running locally. Once we have everything running locally into our development environment, we'll containerize everything, get ready to deploy all of that into production. Finally, we'll migrate everything, because of course we'll be using a database in a container for starters, but then we'll migrate everything to a cloud database. Surprise, surprise, it's Atlas. And then we'll deploy everything on Kubernetes, and then we'll connect to our Atlas cluster using the operator. So this is what we're going to cover today. So as I said, for those of you who just joined in, this is the link if you want to follow along. I'll leave it on for just 1 second so that you can take a picture. And if you don't follow along for today, you'll be able to do it at your own pace afterwards if you need to. Oh, there's a lot of, I should put myself in front of it. Okay, are we good? There's a couple more cameras. I'll just wait a second. Cameras. Who says cameras nowadays? Phones. All right, MERN stack. What is a MERN stack? Not everybody here said they were JavaScript developers, so let's actually go through the details of the MERN stack application. First of all, it's a 3-tier application architecture. So you're probably somewhat familiar with that, where you've got a backend, and then you've got clients that connect to an API. And then you've got a database as well. So your backend will connect to the database, and then your clients or applications running in a browser will connect to that backend. So when we're talking about the MERN stack, we talk, of course, of MongoDB. MongoDB is your database in this case. Then the E stands for Express Server, which runs on Node.js. So that's the E and the N. And then we've got React running on the front end. So we've got a React application. We've got a Node.js backend running Express, which is a framework. And then we've got our database, which is MongoDB. So what I'll do now is that I'll actually start a container for MongoDB. I'll start my Node.js. I'll kind of show you what the code looks like, just so you have an idea of what the MERN stack looks like. And then we'll do the same for the front end. So we'll just look at what we have inside of our repo right there. Now for this application, I was trying to find the simplest application that I could. Of course, I didn't want a to-do app because we've had enough of that. Plus, even a to-do app is somewhat complex. Like there's a lot of updates. Like I wanted the simplest one that I could get. So just a simple application I will write into a database and then pull out all of the records. And that kind of reminded me of back in my days, GeoCities guest books. Like those were great. So you just have a form and people would say, oh, how awesome your website is, and they just click send, and I would save the information. And back in the days, I don't know, like back in my days, people were nice on the internet. There wasn't any trolls or anything. So, so no authentication whatsoever, just put data there. So that's what we'll do. So my MERN application has the following components. So we've got our MongoDB that will have one collection for all of the entries in our guest book. We'll have our Express server. It's an API, so it has two routes. One to post a new entry into our database, and then one to get all of the entries. So very, very simple stuff. And then we've got our React application, which just has one simple route that will both contain the form and all of the listings. All right, so let's get coding. Let's get started with this application. So if you've looked at the URL earlier, you've got access to this application. So you have here, as I said, you've got all of the content. So if you want to go at your own pace afterwards, just go through that. Essentially all of the introduction and everything that I will also mention is also part of this script here. I'll skip the environment. I obviously have everything ready because I gave it a dry run earlier, hoping that everything will still work today. But you can take a look. There's all the requirements. So what we'll need is Minikube. I'll be using Minikube. I've tested everything. It works perfectly on a Kubernetes deployment in DigitalOcean. You'll just need to install a load balancer on top of it, but everything works exactly the same. Yeah, so I've tested on Minikube for this one. You'll need kubectl as well to manage everything inside of your cluster. All right. So MERN stack, what is the MERN stack? I've already covered that. Let me just make that full screen. All right. So let's go into the application, and the first step is, of course, to clone the repository. Now I'll need to find my terminal window. There it is. That's my other presentation. Okay. So I'll clone here. I'll put it in a new folder, and we'll switch to it. And dbw, there it is. Okay, so I now have my application. And we can go through it, just take a quick look. This kind of describes what I have in there. But I'll just open up VS Code. That better? All right, we'll open up VS Code and take a quick look at what we have in here. So as I said, we've got a MERN stack application. So there's a backend. In the backend, I've got a single file. So it's my full server. So it's written in Node.js. And you can see here, if I scroll down, basically there's connecting to the database. So there's a function for that. And then as we scroll down, there's a health route, which is often used in Kubernetes to make sure that your service is actually up and running. I've just used the standard. Then we've got the get entries that I've introduced at the beginning. So that will be our route that will return all of the entries. You can see that it's connecting to the database, and it does a find just to return everything. So no matching, no filtering, just retrieve all of the records. Then I've got my post to /entry, which will save an entry into our database. No filtering, no nothing. I just take whatever from the form and just store it in the database. Probably not the safest thing to do, but hey, it works for this application. I have a /flush just to drop the table or the collection to make my life easier. And then we've got just a little bit of logging. So that's all you need for this server. So it's relatively simple. I like JavaScript, but I love the language, and I like the fact that you can use it both front end and back end. And I kind of like the structure of Express as well. For our front end, let's take a quick look at what it looks like. So basically, we've got an application. I won't go into the details of what is React, but it's kind of a framework or a library to write applications, front-end application. And it has this syntax where you use, air quote, HTML inside JavaScript. Happy to talk about it later on if you want to, but you can see here that I've got my label, I've got my form, so just my name and message, so 2 input fields. And then I've got my submit button as well as a clear button, because that was very trendy in the 90s. Like, all the forms needed a clear button. I don't know why. And then I just list all of the entries. So whenever there's entries, I just use this new component that I've built, which just displays the entry. So this is the application. There's not a lot to it. As I said, I tried to keep as simple as I could here. All right, there's a couple of other folders where I store some example Docker files if you want to browse through it later on, as well as the Kubernetes file, all the definition files are in there. All right, so let's get started. Let's actually get this application up and running. So the first step will be, well, we'll need a database. So we'll just create the container, and I'll get back to what a container is in a couple of minutes. For now, just bear with me. I'll just use Docker run. Boom, I've got a MongoDB instance that is now running on my laptop. So if you're not familiar with containers, that's why it's cool. So I didn't need to install MongoDB. I didn't need to do anything. It's just this command. It started. It's all configured. Everything works right now. As a matter of fact, I can prove that it's working. I can use the Mongo shell tool, and I can just log into my database. And you can see that, I'm inside my database. I can see the databases. There's, well, nothing right now, but. OK, and then I can exit from this. We can do Docker PS just to see what is running, and we can see that that was quick, Docker PS. And we can see that we've got this single container running on my machine. OK, so now we have a database. Now's the time to actually get started and start the backend. So the first thing we'll need to do is to cd into the backend folder and then run the npm install. npm install, there it is. So if you're not familiar with JavaScript development, all you do is patch a bunch of libraries together. It's pretty much our job. So you need to npm install to download like half of the internet, and then everything works. So npm install. The backend was actually very slow. Just wait, the front end is long. OK, we'll need to add a configuration file. So I'll just create a .env file, and I'll use a library that will convert those into environment variables. And I'll be able to set my environment variables inside of that file. So I created .env in my back folder. And I've got port and my connection string, which connects to user path / at localhost, which is the container that I have running. OK, next up, running the application. Node . It'll just find the index.js file and start that server. And we've got it. So server started on port 5000. So everything seems to be working so far. OK. Now's the time to test that server. So we can do a curl command to that /health route. As I mentioned, it's a nice way to be able to test your server. So let's open up a new tab, curl. And perfect. We've got the connection status. OK, and database is connected. So we know that everything is up and running. So far, so good. Time to start the front end. So we'll go to the front end folder and run that npm install library again, or a command. Npm install. Yeah, as I said, just a little bit longer. Yeah. I'm actually glad with the internet connection at this conference center. It's actually pretty decent. OK. So npm install, everything is running. I'll just need to verify that my source/config.json file is connecting to the right server. So let's go and validate that. Source config.json. So it's connecting to, it'll be connecting to localhost 5000, which is the node server that I've just started. So that's good. And now I can start the application using npm start. Where is it? npm start. Right, that'll also take a second. I wasn't expecting it to open in like my messy window. All right, so we've got our guest book. As I said, like I love GeoCities. I see people laughing and they all have gray hair. Okay. Awesome page, dude. All right, submit. Boom. Okay. So cool. We've got our application. Everything is running. Everything is working locally. Very happy with that. Test it out. Perfect. Done. Next step will be to put everything into containers and get ready to get cloud native with all of this. Before we do that, let me just find my, this must be so like making you all dizzy when I'm switching between the screens. I'm sorry, terribly sorry about that. But it is what it is. Containerize all the things. So very quickly, for those of you who are not familiar with containers, I love this definition from docker.com. So containers are a standard unit of software that packages up all code and all of its dependencies so the application runs quickly and reliably from one computing environment to the other. So that's really the gist of it. Basically, a container is like a big zip file which contains all of your source code in the case of a JavaScript application, as well as everything that you need to run it, including basically the operating system, the runtimes, like the configurations, everything that you need to run this application will be inside that container. And it will spin up, and then it will reuse all of that environment every single time. So that's why people start talking about it, because you could just literally use exactly the same thing that's running on your machine, deploy that somewhere in the cloud, and it will run exactly the same. At least that's the theory. Sometimes it doesn't, but it should, in theory. But it makes it, you know, it kind of really solves that works on my machine type of problem. If you've got a QA team that's trying to run your application, and it's like, oh, no, it's not running, but they're running node 14 and you're using node 18, and it's like, no, there's always conflicts, right? So it really helps with that, making sure that the environment is always the same. Another thing that is important to know about containers is that they're ephemeral by nature, which means that once you take it down and spin it back up, it will start fresh every time. They are meant to be easily disposable of. People say think of them as cattle, not as pets. So you should be able to easily just destroy your container and spin up a new one to replace it. That's very convenient when you're on a Kubernetes cluster, for example, and you need to scale your application up. Just put in more containers. That's all you need to do. And then they'll be able to all respond to your requests. And once you're done, you can just tear them down, just destroy those containers, and you're good to go. All right, so back to our MERN stack application. So we have those three different components inside of our cluster, or inside of our application. And then we'll make sure that we've got everything containerized. So the MongoDB part, that's already done. I already had my container running MongoDB. I've just used the image that is available on Docker, which is an image maintained by Docker. If you want, you can also use the image for MongoDB Enterprise. Then you'll need to build your own image, but there's all the documentation on our website. Next up, we had our backend. So for that, we'll need to package a container. They all start from Linux. That's kind of the base of any container. Then we'll need to make sure we've got all of the Node.js runtimes. And then we'll need to copy over that index file as well as all of those node modules. That's very important. Those node modules, they will be slightly different depending on the environment or depending on the operating system on which you install them. So I've installed npm installed on my laptop, on the Mac, and my node modules will be slightly different than if you run that same command on a Windows environment, for example, or on a Linux environment. So you've got to make sure that the node modules folder, you don't just copy over from your local environment. You need to run that command on the container. Finally, we'll have our front end. So what we'll need here is, we don't want to run that npm run as I did. We don't want that whole development environment. We want a container that will be ready for production. So we want the three final files. We want an index.html. We want a main CSS file as well as a main JavaScript file, and that's what we will store on the container. And we'll store that on a container that has Nginx installed. So it'll be able to serve those requests really, really fast, and it will just have those files, those 3 files, and it'll be much, much, much faster than trying to containerize our full development environment, and much safer too. All right, so backend contains Node.js, the runtimes, a single JavaScript file, and all the dependencies. Frontend container will be a little bit trickier because we'll need to create those 3 files. So we'll need to do a build step, but we'll store everything into a container at the end, and then MongoDB. Let's get going. All right, so what are containers? I've got more information if you're interested in on this talk by yours truly. All right, the first thing, if you're following along, you'll want to just export this. That just makes it everything easier. I'm actually going to use my own name. So this is your username for Docker Hub. Where was my, I can stop this. We'll also stop the one running locally because we want containers now. All right, export Docker Hub username equals Joel Lord. Perfect. You can technically use it, but you won't be able to push your images, but you should be able to retrieve the images from the Docker Hub cloud registry. Okay, let's create a Dockerfile for the backend. So the backend is slightly simpler than the front end. We'll start there. It's a nice little introduction to containers. So we'll go to our backend folder, create a new file, Dockerfile, and let's actually take a look at line by line here. Every container will start from a base image, so you never start from scratch. You always start from an image that exists. You could start with a very, very bare-bone Linux image and then install all of your Node.js runtimes and do everything yourself if you want to. But there's also some officially maintained images, especially for Node.js. They've got a very good set of images that are there. So in this case, I'm going to start from this Node.js image. I'm specifying a version number. You should go as far as you can. So minor dot revision if you can. The reason why you want that is to make sure that every time you build that image, it's always using the exact same base image. So you don't have conflicting versions between the containers that are running this Dockerfile. I'll stick to this one just because I have the image cached on my machine. The next step we'll do is that we'll change the working directory inside of your container. So everything that will happen here will be to create that container. So we're doing a build process for a container, and everything is happening inside of that container. So you need to keep that in mind. So I'm changing the working directory inside that container to /opt/app. And then I'm copying over my package.json file into that container, into that /opt/app folder. So this will enable me to do the next command, which is run npm install. And this will install all the dependencies exactly as I did locally, but it will do that, everything inside that container. And once this is done, I can then copy over the rest of my source code. In this case, I only had one file, so I'll just copy that single file. It's good practice to do the layers in that specific way. So copying your package.json first, then running the npm install, and then copying your source code. There's a good reason for that. Docker has a very good caching mechanism. And every time you create a layer, it will try to reuse the layer that is already in your cache. So you want to put the things that change the least often at the top of your file, and then going all the way down to the things that change very frequently. So you can leverage that cache as much as you can. There's more description on that. I won't go into the details of that. The final thing that we're going to do here is that we'll specify CMD, which is the command to run when this container is started. So we're specifying when this container is ready to go. Just run node dot once again, exactly as I did locally. So I wanted to do that local part to show you how the things are exactly the same in my Docker container. So I'll copy the content of this container, paste this in here. So that's all I need for now. And now I'll need to build my image. So to build an image, you would use docker build, the command docker build, -t to specify a name for that image, a tag. Then give it your Docker Hub username if you want to push that to Docker Hub afterwards, as well as a name for that specific container. I will not build the image because I have everything installed, cached locally, and I don't want to mess anything up. And even if the internet connection seems okay, I don't trust it. So the first thing that you would normally do is to build that image. And if you're doing it on your own, you'll have to do that build step. You'll need to log into your Docker Hub account. So there's a free account, free tier available if you don't have an account yet. Or you can use your own registries if you want to. So log in, and then you will push that image to that registry. So that'll push that image, and then everybody, including Kubernetes clusters, will be able to pull that image down to run it in a different environment. Once you've got everything, you can start that container. It'll use the image that is available locally by using docker run again. So same type of command as I used for my MongoDB server earlier. Docker run, -d runs it in the background, --rm cleans afterward. I'm giving it a name so that it makes it easier if I want to do scripting or if I want to delete the container afterwards. It also gives it a random name, which is not very convenient for scripting. Mapping the ports. So in theory, those containers are not accessible by anything else on my machine. I need to actually map different ports. I need to tell Docker any request on port 5000 on my machine will be mapped to that container on the port 5000. Then I specify my environment variables, so the port as well as the connection string, and then the name of the image. So that will start my container. All right, now we can try to curl that container. So curl localhost 5000/help. And we've got status OK, all good. But then db connected false. So that kind of makes sense though. As I just said, containers don't know the existence of each other. There's no way for them to communicate to each other. And that's a big benefit when you're dealing with containers. That's your security there. They're unaware of the host, and they can't find each other. So we'll need a way to map those two together and to make sure that they know each other. To do that, we'll need to create a Docker network. So we can start by stopping the containers. So let's stop MongoDB, stop MERN Kate's back. It'll try to gracefully stop it, so it takes a second. And then I'll use this command, docker network create, and that will create the entries inside of an internal DNS. This one is already created on this machine. But now if I restart my database, you'll notice that I'm adding --network, MERN Kate, so I'm adding it to the network. And what this will do is that it will create an entry in the DNS called MongoDB, and it will give it the IP address. So now if I have another container running on the same network, it'll be able to find it by using the name MongoDB. So I'll restart my backend on that same network again. And now if we curl, all right, so it connects again. Good. So that works. Let's do the same thing for the front end now. But as I said, this one will be a little bit more complex. So let's start by creating the Dockerfile in the front-end folder, Dockerfile. And let's take a look at what a Dockerfile for a front-end container will look like. Now, there's a couple of reasons why it's a little bit trickier than the backend. First of all, as I said, we need to start by building the application so we get those three files we want, that HTML, CSS, and JavaScript file. So we'll need to first start by creating that build process, running that, and then copying those files over into an Nginx server. So that's the first reason. The other reason is that it's really hard to get environment variables working in the front end. The main reason for that is because, well, that front end is running in a browser. So it has no idea what are the environment variables on the server, and there's no way for this application running on your browser to be able to communicate back and extract that information from the server. So we'll need to jump through a couple of hoops to make that work. So the first step is to, once again, start from a base image. So I want to build my application. I wanted to almost run it the same way as I was doing it locally. So I'll start from Node.js, because remember, I installed all the dependencies and so on. I will need JQ. JQ is a command line tool that enables you to interact with JSON in the command line. Very useful tool. Just trust me, that's how you install it. Then I changed my working directory, /opt/app. Once again, it's a very standard one. I copy everything over. That's bad practice. I just told you not to do that, but that's what I do here. Trying to keep it somewhat simple. And then I run this command. So JQ, 2 entries, pipe, map, values, key, $key, reduce as items, $item to config JSON. All right. So there's a lot going on into this command. What this command will do, it will actually find that config JSON file, and it will change whatever value. So it'll look for any key in there, and it will change the value to $key. So it'll just change that value to be $base URL. And then I'll be able to override that later on with an environment variable. All right, so what this huge command does, it just converts all of those. If you added more entries into that config JSON file, it will also override those, so you could add multiple environment variables if you needed to. All right. Next step, we'll run that npm install, and then instead of using npm start as we did earlier, we'll use npm run build, and that is the process that will create our HTML, JavaScript, CSS files. Next thing we'll do is to start another build process. So basically, as part of the same file, we're using a from command again. And this will tell Docker that we're now creating another container, or another stage, and it will only use the final stage as the official container that will be then deployed in the registry. So we're starting from an Nginx server in this case, and specifying an environment variable here. I'm copying this script file. And what this script file does, it's actually all detailed here, but it just looks for those $base URL and replaces that with the value of the base URL environment variable on the server. So there's a little of bash black magic going on there, but basically that's what it does. So it checks for anything and just overwrites your JavaScript file with the value from your environment variables. All right, then we change the directory to /usr/share/nginx/html, which is the default folder from which Nginx serves its files. And then we copy from the first stage, we copy the 3 files that we had, our index, main CSS, and main JavaScript. Then we change the entry point to that start Nginx shell script that I've shown you earlier. So what will happen is that every time that container is started, it will use that script, overwrite any environment variables inside of your JavaScript code, and use those environment variables. So if you change your environment variable, your container will go down, it will spin up a new one, and it will use those new environment variables. All right, so this is what the code looks like. You can go ahead, oops, not overwrite that. Copy this here, and I've got my front-end image. Again, I'm not going to do the Docker build, Docker push, but we'll just start that container. Right, note that I didn't use the -- network in this case. We don't need it because it's actually looking for localhost 5000, so it's not looking for an internal service running on the same network. So now, if I go to my browser and I try localhost 5000, it should work. Oh no, not 5000. That's why. 8080. All right. Thank you. Okay, so now we've got, this is our container, so it's now running. Note that there's no more data inside of our database. That's because I stopped the database at some point to connect it on a different network. So I've lost all of my data. Not very useful. But now I can start and I can add more data to our form. All right, I think that's it for the containerization part. If you're interested, you can also use Docker Compose, which is like just one big script to start multiple containers. It can be useful. I won't go to the details of it, but you can definitely use it. All right. Now, I was using MongoDB inside of a container that worked perfectly, but ideally we want to be able to move everything from the cloud. Managing a container that has to persist data is a challenge, so it'll be a lot easier to migrate to the data. Not only that, but trying to, and using MongoDB Atlas also brings you a lot of benefits. again, I won't go through the details. I'm guessing everybody attended the the keynotes today. Basically, the one part that is really important here is the multi-cloud part. Trying to do that when you're running your own containers is a lot of work. So that can be very useful to use MongoDB Atlas in this specific case. So we'll use MongoDB Atlas, just create that account. Cloud MongoDB. Right, I've got a MongoDB instance running. I've got a cluster already up and running. And that's it. I mean, you can just go ahead, create a new cluster if you need to. We could create a free cluster in this case. Just start a cluster. This will take a couple of minutes, but it's just a couple of clicks and you're able to create that cluster. You'll be able to connect to it. I'll just go ahead and get my connection string. I'll use this one right here. And I'll be able to use that for my backend server now instead of using that container. All right, so what is MongoDB? How to create? Yeah, make sure that you set up the permissions. Never use 00000. Not the first one to say that today. Create your database, get the connection string, and now we can export that connection string. So Atlas connection string equals the one that I just copied. I'll go change my password. Perfect. All right, so now that I have this connection string stored in a local environment variable, I'll be able to use it more easily. So I'll start by stopping my existing containers. Let's just stop all of those. It'll try once again to gracefully stop those, so it takes a second. And then I'll just restart my front end and my back end. So I don't need a database container running anymore because I'm now using my Atlas cluster. Start the front, start the back. And if I run Docker PS, I should be able to see only 2 containers now that are running. Right, so once again, I can test this application, still on localhost 8080, and you can see those entries that were already in my database from previous testing that I did. So now I'm connected to my Atlas database. I'm getting much closer. I've got everything set up into containers. I've got my my database that is now using Atlas, so that works as well. If you're using the Docker Compose file, you could take a look at this, but basically I'm removing the database and just changing the connection string here. All right, let's finally get into the Kubernetes piece. So we've got all of our containers, now we want to use Kubernetes. If you're not familiar with Kubernetes, this is the official definition from their website. Kubernetes, also known as K8s, is an open source system for automating deployment, scaling, and management of containerized applications. So that's what it does. The only thing that it does is to start containers for you and stop containers when you don't need them. So that's pretty much the only thing that Kubernetes does. So what's the hype? I don't know. No, it does a lot more, but essentially it breaks down to that. It takes care of all of that scaling for you and makes it very, very easy, but most importantly, it takes care of all the networking. So if you spin up multiple backend containers, it'll automatically take care of doing the load balancing between all of your different services, distribute the requests, and it also all the networking that we needed to do earlier for making sure that our backend can communicate with a database. It has its own DNS internal services, so it takes care of all of that for you. So it does a lot behind the scenes. And it just makes working with containers so much easier. So this is our Kubernetes cluster. This is what it will look like. So in a Kubernetes cluster, you will use deployment. So deployment is a description of what you want running at any specific time. So we'll specify, I want to run 2 containers for my backend. I say containers here in Kubernetes, we'll talk about pods. Pods is a group of 1 or more very tightly related containers that will run together. And when I say really, really tightly connected, we're talking about like a backend that would have a monitoring service. A backend and a front end should not go into the same pod. Really, you want containers that will live together and die together if it happens, but you don't want your backend to go down at the same time as your front end. So those two you'll keep in different pods. So the deployment specifies I've got those two pods that I want running, and we'll have a service. The service will expose those pods into the rest of the Kubernetes cluster. So this is what we'll have for our backend. We'll have something very similar for the front end as well. So we'll have another deployment. The deployment will be in charge of making sure that we've got two pods running the front end at any given time, and then we'll have a service exposing those two pods to the internal cluster. Now we want to expose those to the outside world because ultimately we want everybody on the internet to be able to see that. So we'll use an ingress. An ingress is an entryway or a door to your cluster. We'll have different routes. So you will have one ingress, but you'll specify different rules to direct the traffic to the appropriate services. So I'll have a /API route that will redirect the traffic to my backend, and then everything else will just be redirected to my front end. And then you've got your database. As I said, managing a database with containers is very complex because you need to persist that data. So you need a deployment to specify how many pods you want running that Mongo database. You'll need a service to expose that database. You'll need some persistent volumes. You'll need your connection string. You need to implement sharding and replicas. There's a lot of things that you need to do. But let's not worry too much about it for today. For now, let's start by our backend and front-end services. All right, what is Kubernetes? Covered already all of that. You're all experts. We'll start by this little part, deploying the backend. So I'll just go to VS Code, I'll create a new folder for my Kubernetes files. I'll then create new folders for my backend as well as my front end. And in my backend, I'll have a deployment, and we'll have a service. And oops, the same for the front end. There you go. Okay. Every Kubernetes definition file always starts the same way. You start with the API version, so you must specify Kubernetes where to find or where to validate all of the information. You need to specify what is the kind of object that you're trying to create. In this case, we'll be creating a deployment. And then you specify some metadata. Metadata is usually the name as well as some labels. Labels make it easier to find different components inside of your whole Kubernetes cluster. And then you've got the spec, which varies from one object to another. In this case, in the spec, because this is a deployment, we'll say, well, we want two replicas. We want two pods running at any given time. And we'll want, in order to find those two pods, just look for pods that have the following label, component back. So this is what we're specifying here. And we specify the template for those pods. So we're telling Kubernetes, all of the pod that you need to create for our front or back end, in this case, will have the following labels. So it'll have the component back label. And those pods will have the following specs. So they will have just one container. It will have a port 5000 open. That's my back end. And the following environment variables as well. So I'll be using those environment variables that I'm showing you. So this is what my deployment for the backend looks like. I'll just copy this over, change those variables. So I'll be using my own username, and I need my Atlas connection string. There we go. Thank you. And let's change this. All right, this should be enough. I'll create my service as well. So my service specifies, well, I want to expose my pods to the outside world, right? So I'm going to say here, API version, kind, metadata. Again, all of our Kubernetes objects start the same way. And then we've got our spec. We say, well, find any component or pods that have component back as a label. And you'll be the service for those pods. And then I say any incoming request on port 80 will be mapped to those pods into the port 5000 because our backend is running on port 5000 here. So let's just go ahead, copy this over, and we've got everything that we need to deploy our backend to Kubernetes. So I can go ahead, apply those two files. and kubectl applied back. It just created the two, so we can use kubectl get all. That will show us what is currently running inside of our Kubernetes cluster, and we can see that I've got a service for my backend that will expose those two different pods that are right here. They're both running. If you're doing that on your own, it takes a couple of seconds because it needs to download the image into the local registry, so be patient. And then I've got a deployment, which is the one that we've just created. It tells me that I've got two containers that are currently ready, they're running, they're up to date, and I've got a replica set. The deployment, in theory, created a replica set, and the replica set is in charge of maintaining the pods, but that's Kubernetes internals. All right, so now we can test the backend, or in theory, you can try to test our backend, but there's a problem. There's no way for us to access the backend. It's only accessible from inside of our Kubernetes cluster at the moment. Nothing is exposed to the outside world. We'll need an ingress to do that. However, we can at least take a look at the logs to see what's going on. So we can use kubectl logs. And we can see that that my connection string is not working. That's okay for now, hopefully. But we can see that the server is started at least. All right. Next up, I'll create an ingress in order to expose that service to the outside world. So I'll just create a new file called ingress. I'll copy this over and I'll explain it as I copy it over. All right, so same type of thing, API version, kind, metadata. Don't worry too much about this for now. The important part here is that I describe a bunch of rules. So my ingress will accept any incoming requests, but it will need to dispatch them to the services, the appropriate services based on a set of rules. I'll be using path rules, so based on the path of the request, any request to /API, as you remember, will be sent to our backend service, and anything else will be sent to our front end. You could do rules on subdomains as well, so api.example.com would go to your API. There's a lot of rules that you can use. For now, I'll just send all of the traffic, so it uses wildcards. So just everything, just send that to the backend, because that's the only one that we want to expose for now. All right, we can apply this, and it should be created. So now I can run this curl command on my Minikube server, and I should see status OK. I'm getting a database connected false because of a glitch in VirtualBox, which is the virtual machine running. We'll fix that later on. But for now, status OK, our server is up and running, and my traffic is being redirected to one of my two pods, and it does the load balancing as well. Time to deploy the front end. The front end is, for all intents and purposes, exactly the same as the back end. So you can kind of see here, same structure. We want two replicas. We've got the selectors, and we've got the environment variables. So I'll just go ahead, copy this over into a deployment file, change that. And the same goes for our service as well. So pretty much the same thing again. We're just redirecting all the traffic on port 80. Mind you, the container is running on port 80. All right, now we can apply the front end. There we go. We've got our two services that are created. We can do a get all to see what's now running inside of our Kubernetes cluster, and we've got a lot more. So now we've got two services, two replica sets, two deployments, 4 pods. Everything is up and running, and there's no problem here. Perfect. Now I'll just need to tweak my ingress a little bit to make sure that the requests are assigned to the right place. So now let's take a look at this line. So I've got a rewrite rule here. So basically, I'll just take the second argument of the path that was sent, and I'll pass that to the service that I'm trying to connect to. So any incoming request to /API, optional /, and then followed by a request will be redirected to my backend service, and it will just redirect it as the second argument. So /API /entries will be redirected as /entries to my backend. So there's a little bit of magic here. And then everything else is just sent to my front end. So I can go ahead, apply this. If I can learn to type, there you go. And that should be working now. It's not applied. I can test this application. So Minikube IP, I get an IP address for my Minikube virtual machine. If I use this, I can access my guestbook again. There's still that problem with the database, but let's not focus on that for now. Right, last part is that I need to actually connect to my Atlas server. So it's not fully working right now. In order to do that, I'm going to use the Atlas Operator. So operators in Kubernetes are a software that you will install, basically, that will just take care of installing all the different components for you. So you don't need to be bothered with installing all of that persistence. So there's a Kubernetes operator for the community and enterprise versions of MongoDB that you can use. Really what they do is that they install a replica set for you. They deploy like those 3 different containers running MongoDB. There's a lot of things that are taken care of. It takes care of all the data persistence and on and on and on. The one that I'm going to use today is the Atlas operator, which I prefer because I like to use Atlas. And it will just kind of use Atlas or allow me to use Atlas from inside my Kubernetes cluster. So what I currently have right now is I've got my Kubernetes cluster with my backend and my front end, as well as an ingress. But my Atlas server is kind of running elsewhere. And there's no way for me to really communicate. There's a lot of things that are not perfect. As I said, deploying it on your own is a lot of trouble, and we're definitely not going to do that. So what we'll try to do instead is that we'll run everything from within our Kubernetes cluster. In order to do that, we'll need to create a bunch of custom resource definitions. So we'll need to create our own custom objects inside of our Kubernetes cluster. Of course, we're not going to do it. We're going to use the Atlas operator that will take care of that for us. So it will create an Atlas project that will be exactly the same as our deployments or our pods. It will be a new object that is available for us inside of our Kubernetes cluster. It will create that change with the GA yesterday. So not Atlas clusters anymore, but Atlas deployments. And it will also expose the connection string. So our different services will be able to directly access the connection string. And that's a very, very useful feature. All right, let's get going. Last part. All right, what is the operator? Done that. Installing the operator, that's the command for it. It's just a single line. Basically, it will apply the file that is available on GitHub, so you can take a look at the file, because you should never install something from internet directly. I already had it installed, so it just tells me that everything is configured, but if this was a new install, you would just see that everything is now created. Good. Now we'll need to install a couple of secrets in order to make sure that everything is configured specifically for our Atlas server. The first step is that you'll need your organization ID. If you go in Atlas, right here, you'll have your organization ID. You can just copy this over into an environment variable. So export, what is it, org ID equals, and then paste in your organization ID. I already have those, I believe. No, probably not. Maybe. I should check. I don't. Good thing I checked. Org ID. Perfect. And then you will also need to create an API key. So I'll go ahead and create the API key. Access Manager, API key. You can give it a name. And there you have it. So public key, Atlas public key. And our private key. Your private key is only accessible when you create the key, so you've got to make sure that you do it right away, or else you lose it forever and you need to create another API key, which, if you've noticed, this is why I got about like a gazillion different API keys, so I always forget. Now, never do that, but I will give it access to everything from everywhere. All right, So everything is now stored. So now we can create those as part of our Kubernetes cluster. We'll add them as a secret, and that secret will be available for our Atlas operator. So just install those. And then we'll need to add some labels. The labels are there to help the Atlas operator to find the credentials. And next, we'll add a user password. So for our databases need to have a username and password in order to access them and to create new databases and so on. So we'll just create those. Those are already created on my current cluster, so I won't need to do it. All right. So now we've got everything that we need to actually create our first cluster, create our first project, as well as a cluster inside Atlas, but using Kubernetes in this case. So I'll go ahead and create a new folder for my Atlas stuff. Create a new file for our project. Just paste in the code. So again, same type of thing. API version, kind, metadata, spec. So we've created an object that we can now use in Kubernetes. It is of type Atlas project. I'll give it a name. I'll call it Kubernetes 2, because I already have one installed. It's like the kitchen or kitchen show trick. Like, I already have a cluster installed. And then you specify the IP access list, which is never 0000, of course. So that takes care of creating my project. So that will create a new project exactly as I have right here in my Kubernetes cluster. Oh, look at that. I already have it too. But it will create a new one like this. OK. Let's go ahead and create a cluster, which technically is now a deployment. And it should have been updated. There you go. Create a deployment. So deployment. At API version, kind, metadata, spec, same type of thing. The name of the project in the Kubernetes namespace. So it was called like this in Kubernetes. Name of the cluster that I want to start. Specify the instance size. I'm using an M10 just because I'm cheap. You could use a provider. You could put in Azure, GCP, AWS, whatever region that you want out of the 100 region available. I'm just going to use the US East one. This is the fast one. You can also create M0 instances if you want to just play around with it. The code is right here. And finally, we'll need a new database user. So I'll just create that user. Put this in here. So basically, I'm just creating a user and giving it using the secret that I created earlier. I can now apply all of those files. Those were already created in my cluster. So I can do kubectl, get atlas projects. And we can see that we've got a new project called Kubernetes 3. I can also get Atlas deployments. There's a deployment that was started 23 hours ago. And if we look here, and if I list all the projects, I will actually see my Kubernetes 3 that was just created. So I didn't create that one in Atlas. I was actually able to create all of that inside of Kubernetes by using kubectl. From here, you should be able to pretty much do everything that you want to do on your Atlas cluster. Most of the options that are available in the CLI or in the Atlas UI are available for you to use in here. And one really cool thing is that you can actually get your connection string. So the connection string are in a secret called the name of your cluster or the name of your deployment dash the name of your project. I just convert that into JSON to extract the information. It's actually in base64 encoded, so I just switch it back by using this pipe here, using JQ again. And as you can see, now I have access to those connection strings to my cluster without actually opening up my Atlas UI or without actually giving those connection strings to any of my developers. So now my developers will be able to, and let's actually do it, go to their backend, and they'll be able to use that secret directly from the secret key that was created by the Atlas operator. So in my deployment file, I'll go ahead, in the back deployment, I'll overwrite all of my environment variables. So see how I had the connection string manually in there. I'll change my connection string to take the value from a secret, and I'll use the standard connection string here. I've changed my deployment, so I'll do a apply on the back end. There we go. So this change went in. kubectl get all should show us that we've got some containers that are being terminated and new ones that were started. And if I go back to my application now and refresh, you see that I've now connected to my database without actually specifying the connection string. I can just use that value from the secret. So no need to store that connection string inside of your Git repository. You can just use that secret that is now available to you, and you can actually have access to that from the Atlas service directly. So this, to me, was one of the biggest benefit from using the Atlas operator. It just makes everything so easy. You don't need to be bothered with those connection string, and so on. All right. That brings us pretty much to the end of this presentation. So basically, the final result, we've got a 3-node replica set for database resilience. So running on Atlas cluster, I actually have 2 different projects or 2 replica sets running because we're just running tests. So 6 nodes. I've got 2 front ends and 2 backend containers running. So it's very scalable, very highly available, probably very overkill for a GeoCities guestbook, but it works. Tomorrow I'm giving a talk about CO2 emissions and why you should not do exactly all of that for a guestbook page. So come and see me tomorrow if you're interested. So quick recap, we saw what is a MERN stack application, what are containers, how to use them, some of the using environment variables to be able to inject those variables into your containers, and then Kubernetes to make it easy to deploy, scale your application, and use that operator. Just makes your life so much easier. Again, there's an operator available for all the versions of MongoDB, so Community, Enterprise, as well as Atlas. And they are following very, very similar standards. So I think it's, instead of Atlas, the project, it's like Community, I don't know, I'll just stop talking. So that's pretty much all I had. Thank you so much for your time. Yeah, actually, you'll have it on this URL if you look at it. I'll go back to it in a second. Well, actually, why don't I go back to it right now? Whew, there it is. All right. Okay, so that's all I had. So thank you so much for being here. I'm pretty much on time. We have time for a couple of questions if there are any. If not, 75 minutes is a very long session. So I perfectly understand if you want to leave. Take a look at this URL. You'll have the information available if you want to test it out on your own. Take your time, take a look at it. I'm always available on Twitter as well. So it's on that last slide. Now I have to go back to the end. It's actually on that URL. It's not on the slide itself. But if you take a look at this one, you'll be able to find me or just see me during the conference. Thank you.
Thanks everyone for attending. Make sure you fill out any feedback forms for this session and for World, just so we can continue to make World better. And make sure to sign up for any sessions on Wednesday and Thursday. Thanks.
Yes, let's make the world better.